Hi guys, this is Team Logisim, a participant at the SiliconSprint competition organized by IEEE societies at NIT Surathkal and RV College of Engineering. And this is a video demonstration of the work we've done along with the environment we've created to test it. So here is a quick rundown of the VS Code ID that we're using. You can see the following folders inside it. The .vs code folder basically contains the task.json file, which is a JSON file having the script that runs the softwares necessary for this flow to execute, which I'll be showing shortly. In the same file, we have the generated VCD files for viewing the waveform. In the SRC file, it is basically a storage. It does not contribute to the script logically, but you can store the codes that you are working with. In the surfer file, we have the surfer.executable file for the waveform viewing application. And in the work file, we have the main files, which is the design.sv and testbench.sv file. In the design.sv file, we need our RTL design, and to test it, the test bench file over here. Now, to see how this works in action, let me zoom out a bit. I'll show you through the terminal. So now to execute the task that we have written, I have to use the command Control Shift V. Now it starts executing, and as you can see, a terminal has opened, and now Surfer has opened. So Surfer is basically the waveform viewing application that we're using. And here are the waveforms. We can just click them and it will plot on the software, right? Let me close it really quick. And just to show you the log, here the task started executing task, C, whatever. And then the compilation was successful, after which a dump file was created. And here you can see a log of the logic that we are trying to implement, which is matrix multiplication. These two matrices were multiplied, and the expected C matrix is follows. And our computed matrix also matched it perfectly. So it passed completely, and the simulation was opened. This is something that it would look like. I've just opened it on the side to show you. Now to move on to the next part, which is synthesis, I have to give it a yes over here to tell it that I want to run synthesis with Yosis. Once I press enter, it starts doing the synthesis report. It generates the log file, area file, JSON file, and currently it's generating schematic file. And as you can see, it has generated the schematic file. So you can see it is according to the time right now. It is 15:54, and the timing is stored in the names of these files. So 15:54, you can see area report has been generated. And yeah, 689 wire bits, 668 cells, a total estimated count of 4254 plus transistors. And to see the circuit, this is the SVG file that is generated. Let me zoom out. So yeah, now that I've zoomed out, you can see the actual scale of the circuit, how big it is. So yeah, that sums up the environment we were using, and the implementation was of a NPU processing element that is a 4x4 systolic array. Thank you.